There is a heading in my notes, F block element. I want you to come here on F block. Ready, all of you? Right? Now, in F block beta, what all thing we have to study? Position, general electronic configuration, oxidation state, lengthenite contraction is very important. Now, here what we have, beta, this is our periodic table here. Can you see here in third period and third group and sixth period, we have lanthanum to hafnium. So these are lanthanides. These elements are after lanthanide, they are placed below periodic table. Cerium, praseodymium, neodymium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, lanthanides. And below lanthanide, what we have, beta, actinides. So lanthanide, 14 element, it starts from what, beta? Cerium. And it ends with what, beta? Lutetium. हेलो. हाँ बोलो. हाँ नहीं, क्लारी, हाँ आ जा रही. कोई जेवियर्स वाले कोई आया ही नहीं बेटा. मैं तेरे को मुझे भेज देता. तेरा कौन सा टेस्ट है? हाँ मैं भेज देता हूँ. हम सो सॉरी. हाँ बेटा, मैं बताना भूल गया. वो जेवियर्स वाले कोई आए नहीं इसके लिए. ठीक है ना? सैटरडे 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 सैटरडे. तो ये थर्सडे नहीं रखूंगा. हम्म. वो मैं तेरे को अपडेट करता हूँ ना अभी. ठीक है ना? हाँ, यस 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 यस. Now in periodic table beta, if you see F block element where they are placed beta below the periodic table. Can you see here below? This is your F block, lanthanide, and this is your actinides. Right? Lanthanide is last electron will enter into 4F. So they are known as which series? 4F series. Actinide beta last electron enters into 5F. So they are known as 5F series. Now you should know which are lanthanide. Okay? चलो बेटा, F block यहाँ पे लिखा है, वहां पे आ जाते वापस. Okay? Now, if the last electron enters into the last shell, this is my last ultimate. Second last is penultimate. So this is what beta? Pre-penultimate. N minus 2F. We call it as N minus 2F. Last is ultimate. So where the electron will enter beta? Pre-penultimate shell. कहाँ पे जाएगा? 4F में. So this is last. This is second last. This is third last. Third last को we call it as pre-penultimate or anti-penultimate shell. Right? So the electron will enter here. Okay. Oh God. Hmm. How to remember this beta? I have given the mnemonic. Look. This is the mnemonic we will remember. क्यूट पेयर नीड प्राइवेट समर. यूरोप में गांधी जी टेबल पर डाय लगाकर होली अर्गी का तमाशा यूसुफ भाई एंड लालू के साथ देख रहे थे. सो व्हेन आई से आई विल गिव यू अनदर
How do you
mnemonic
come up
also.
with these? How do you come up with these acronyms?
Okay, forget about that. You have to remember. Cute pair need private summer. यूरोप में गांधी जी टेबल पर. You will get the exact symbol. Look, cute, curium, praseodymium, neodymium, promethium, samarium, europium, gadolinium. Table is terbium. Dye is dysprosium, holmium, erbium, thulium, ytterbium. Yusuf Bhai is ytterbium. Lalu is lutetium. Now, in exam point of view, what you are supposed to remember, beta? Here, lanthanide are, first we are going to study about lanthanide. In lanthanide, beta, you should remember they are first in a transition series. Rare earth metal, they are 4F series. Lanthanides are also known as lanthanoids. They are also known as lanthanoids. First in a transition series, rare earth metals, 4F series. In exam, they will ask you, they belong to which group? Group 3. Which period? Sixth period. Remember, La is not an F block element. La is a D block element. La ke afterwards. Remember, beta, where was La? La was here. Can you see? La lanthanum is in D block. Lanthanum, अरे यार चलना भाई क्यों नहीं आ रहा है? Lanthanum is a D block element. Here these are F block. Can you see? So it starts from cerium, ends with lutetium. In exam they will ask, lanthanide series starts from cerium, ends with lutetium. Total 14 elements. This is very important. General electronic configuration. Na2, N-1D, 0 or 1, N-2F, 1 to 14. Now when I say lanthanide, atomic number is 57. So how I'm going to write it? When I write xenon, so 54 electrons are gone. Then 2 here, 56, and then here it will be 57. Lanthanum में last electron enters into D. बट सीरियम होगा ना बेटा तो यहाँ पे क्या आएगा 4f1 में जाएगा. F में कितना जा सकता है? सो दिस इज जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन. This is very important. Only whatever important thing is there for exam point of view, I have given in the notes. For lanthanides, general electron, if for N, if I put 6, so N minus 1 is 5, N minus 2 is 4F, and xenon, because they are after xenon, na beta, 58 से start होता है, देख बेटा. Clear? Now, who has half-filled configuration? They will ask you. So you have to remember, europium and gadolinium, they have half-filled. ये F में how many electrons can enter total? 7 are there ना, तो how many electron can enter? 14. तो 14 का half कितना होता है? 7. 4f7, 4f7. For here it is 6s2, here it is 6s2, 5d1. Who has half-filled? Europium and gadolinium. Who have completely filled means 4f14. Ytterbium and lutetium. 6s2, 5d1. Clear? Now in exam they will ask you which is the most abundant lanthanide. Most abundant is which one? Cerium. Only radioactive is promethium, PM. Promethium is the only radioactive. Most abundant is cerium. This all you are supposed to remember. Then beta, we are going to do very important thing, that is oxidation state. Now what type of question? Zia beta, now tell me if an element is in group 1. What is their oxidation state? Like sodium, potassium, what is their oxidation state?
1.
+1. Very good.
Yeah,
If it is
plus
in
1.
any element, if it is in group 2, then what is their oxidation state? Like magnesium, 2 plus.
Plus 2.
So they belong to which group? Lanthanide group क्या था बोलो बेटा? They belong to which group? Tell me.
Oh, this thing.
Group 3. Look, I have circled,
Yeah.
na? So what is their common oxidation state? Exam में they ask very frequently. What is their common oxidation state? +3. Why? Because they belong to group 3. So they will lose 3 electron and they will form N+3. But some element can show oxidation state of +2 as well as +4. What is the condition for +2? +2 oxidation state is shown by F7, जिसका भी F7 होगा या F14, by loss of 2 electron. And you have to remember only 2 examples. Which are the 2 examples? This will have by heart, beta. Which are the 2 examples where F7 and F14 can be attained? Europium and europium. Can you see? It was 4f7, 6s2. It loses 2 electrons. So I'll get exactly 4f7 or not? Tell me. Europium. So in life, europium gets opportunity to become plus europium beta. If it gets opportunity to become +2 or +3, what it will try to become? Which one is most stable? Common oxidation is +3, but F7 na beta here. So it is the most stable. So look, I have written most stable oxidation state of europium is +2. Next is which one beta? Ytterbium. Ytterbium atomic electronic configuration was 4f14, 6s2. If it loses this 2 electron, it will become 4f14 or not? So if ytterbium, if it gets opportunity to be the most stable oxidation state of ytterbium is +2. This is the lowest oxidation state. In exam, they will ask, what is the best condition for +2 oxidation state? So what will say? F7, F14. Example is europium and ytterbium. Will you remember this? What is the best oxidation state for +4? +4 के लिए what is the condition? F0 and F7. This two only will by heart. Cerium, if it cerium, or this is the electronic configuration. If it loses 4 electron, can it become 4F0? Let us see. दो यहां से जाएगा, दो यहां से जाएगा, तो it has become 4F0. So cerium most stable oxidation state is which one? +4. Similarly, terbium. Terbium was 4F9, 6S2. It loses 4 electrons. So what will happen? 2 will go from here, 2 will go from here. So it will become 4F7. Clear? Hello. So the most stable oxidation state of cerium and terbium is +4.
Yes.
So now what was the range, beta? +3, +4. This is the highest oxidation state or not? Tell me, +4. And the one who are in the
Yes.
highest oxidation state, they are strong oxidizing agent. Give reason. They will ask you. Cerium and terbium are strong oxidizing agent. Why? Because they are in their highest oxidation state. Now they can
Highest
only get
oxidation state.
reduced. Clear?
Yeah.
Now there is one
Yes.
element which you'll have to by heart, which shows all the oxidation state. Which is the element which shows all the oxidation state? Exception. Naughty neodymium. Neodymium shows all. Now in exam there will be question asked. Write a short note on oxidation state of lanthanoids. So what all thing you'll write? You'll write this entire page. First, what you'll write? Common oxidation state is +3 because they lose 3 electrons. But sometimes they may show +2 oxidation state by losing 2 electron, F7 and F14. So europium and ytterbium. Then beta, you will write, they can also show oxidation state of +4 by attaining F0 and F7, cerium and terbium. And neodymium is what shows all, name an element which shows all the three. Acha, the element which are in the highest oxidation state, they will act as strong reducing agent. You can write cerium and terbium. You just write here, strong oxidizing agent. Element in the highest oxidation state act as strong oxidizing agent. Written, रायन बेटा लिख ले ये.
Yes, sir.
Now what question they will ask? Look here. In textbook page number 191. What question they've asked? Cerium and terbium behaves as good oxidizing agent in +4. So what you'll write, beta? It is their highest oxidation state. Okay, therefore they will act as a strong oxidizing agent to reduce their oxidizing agent. Zia, the one which are in the lowest oxidation state, they will act as which agent? What is their lowest oxidation? अरे बेटा देखना, +2 वाला क्या है?
Reduction.
+2 is lowest, so
Reducing
they are
agent.
reducing agent. +4 are what?
Oxidation.
Oxidizing agent, right?
Yeah.
So here also we'll write cerium, this thing. Europium, and which one was +2 beta? Tell me. Europium was +2 and ytterbium. Please write here, strong reducing agent, because they are in their lowest oxidation state. Have you written this?
Yes, sir.
Now what question they will ask? Look here. The spelling is wrong, ytterbium. Europium and ytterbium act as a strong oxidizing agent. Clear? Will you be able to do it? Hello. Clear? So this was all about your oxidation state. Right? चलो बेटा, नाउ वेरी इंपॉर्टेंट क्वेश्चन, बोर्ड में बहुत बार आया है. ओके, कलर. अच्छा बेटा, कलर वी हैव स्टडीड इन डी ब्लॉक और नॉट? टेल मी. डी ब्लॉक कलर इसमें नहीं पूछते ज्यादा, फिर भी आपको मैं बता देता हूँ. ए, डी ब्लॉक में how many are there? 5. 5 is to break into what? 3, 2 ना बेटा. So here how many are there? Zia, look, how many are there? Seven, na beta? So they will break into
Yes.
4-3. अच्छा, वहां पे D block में क्या पढ़ा था? Color is due to which transition? DD transition. Here color will be due to what?
Yeah. FF
FF.
transition.
अच्छा, but here what is the condition for color? Colorless के लिए क्या condition है?
Has to be
F2 to F6 and 8 to 12.
12.
हाँ, but you will say, sir, in D block, we have studied D0 and D10 were colorless.
Degrading
But why
data.
here?
Yeah.
So here there are few exceptional cases. Even I can see color only
Mm.
in the visible range. So now look, F0 and F14 is completely filled or not? Tell me. F0,
Yes.
La3 plus F0.
Mm.
And this is F14. F0 तो बेटा एक भी इलेक्ट्रॉन होगा ही नहीं अंदर. There is no electron, so no jumping of electron, no FF transition possible. Here
Yeah.
F14. F14 is also completely filled or not? Tell me. So no FF transition
Yes.
possible. So Lalu is colorless. La and Lu is color. That is understood. But you will say, sir, why F1 and F13 are colored? Because here, in case of cerium, absorption is in which light? UV light. Human eye cannot see UV. Ytterbium beta, it is absorbs light in which range? Infrared. So infrared is also not visible, right? Then, beta, they will ask, this is very important, huh? Why gadolinium plus 3 does not undergo FF transition? Why? Because, beta, this is half filled. As compared to D5, half filled is more stable. F में टोटल कितना इलेक्ट्रॉन जाता था? 14, right? So वो ब्रेक ही नहीं होगा बेटा. F7 will not break. Why? Because it will destroy its half filled configuration. It is stable. It will destroy its symmetry. And secondly, it absorbs light in UV range. So why gadolinium plus 3 is colorless? तो यहाँ पे दिया है बेटा, ये देखो, gadolinium plus 3. Electronic configuration of gadolinium, right? So what you will write, it is half filled. So बेटा भी एग्जाम में आपको खाली कलर के बारे में पूछेगा तो कर पाओगे बेटा, राइट? ओके, अच्छा बेटा, whenever it is F0, what it will be बेटा? F0 and F14 means no unpaired electron. अरे देखना बेटा, F0, so this is diamagnetic.
Yeah.
Lalu,
Huh.
this is also diamagnetic. Clear? Rest all will be
Yeah.
para.
Correct.
Now this is very important question. दिया आएगा lanthanide contraction, 100% आएगा बेटा बोर्ड में. अच्छा, D block बेटा, we have studied in S block the decrease in size is very rapid. In P block also it is very rapid. D block it was what beta? Decrease was there but comparatively less. But in F block beta, this overall decrease is very, 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 very less. Overall decrease is very, 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 very less. Why? Because F में इलेक्ट्रॉन कहाँ पे एंटर करता है बेटा? थर्ड लास्ट शेल में. याद आ रहा है कि नहीं? 4F में एंटर करता है कि नहीं? 4F में. Because here the in D block में भी less होता था. Why? Because it used D block में electron used to enter in D, second last shell. Here the last electron will enter here. So beta, as you go from lanthanum to lutetium, atomic number is increasing, nuclear charge will increase, तो nuclear charge अंदर बुलाएगा. लेकिन electron is entering into what beta? An inner screening or shielding effect will increase or not? Okay, so due to increased shielding effect, overall decrease is very, 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 very less. Overall decrease is very, 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 very less. So एग्जाम में क्वेश्चन विल कम, व्हाट इज lanthanide contraction? देखो बेटा, ये टोटल 14 एलिमेंट्स है. कैन यू सी जिया? ला विल बी बिगेस्ट, देन दिस, देन दिस, देन दिस, बट ओवरऑल डिक्रीज इन साइज इज हाउ मच बेटा? ओनली 15 पिकोमीटर्स. मतलब एक
Hmm.
एलिमेंट का अगर हम लोग देखेंगे तो कितना? टोटल 15 एलिमेंट्स, 14 एलिमेंट्स हो गए, तो एक का डिक्रीज कितना हो रहा है? ओनली 1 पिकोमीटर. ओनली
And
1 पिकोमीटर.
yeah.
So this overall decrease in size is known as what? Lanthanide contraction. And this is their
Hmm.
ionic size. Overall ionic size decrease of all the 14 element is how much? 20 picometers or 0.2 angstrom. Now, why you should know this? Because in MCQ beta, they will give you this element and they will tell you to arrange them in the increasing order or decreasing order. So you should know. Therefore, you should know that क्यूट पेयर नीड प्राइवेट समर यूरोप में गांधी जी टेबल पर डाई लगाकर होली अर्की का तमाशा यूसुफ भाई लालू के साथ देख रहे थे. So that it will help you to arrange them. So overall decrease in the size with increased atomic number is known as lanthanide contraction. Look, beta, this is their general electronic configuration. We have done this. What is their general electronic configuration? NH2. I have given this, huh, beta. Then, beta, their electronic configuration also we have done. Electronic configuration with whatever I have done, only that you will do. Oxidation state also we did, right? Then this color thing also we did, right? This is what is important. Okay, overall decrease in their size. Look, beta, lanthanide atomic size decreases across the period, right? But this overall decrease is very, 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 very less. Of all this, overall decrease is very, very less. If you see, the overall decrease is only, decrease in size. Look, can you see this? Atomic number will increase, so atomic size is, but overall decrease is very, very less. It is how much only, beta? Tell me, 15 picometers. If atomic size, and ionic size, it is 20 picometers. This overall decrease in size with increased atomic number is known as lanthanide contraction. So definition they will ask you, beta. Look, atomic number is increasing or not? Look, atomic number is increasing. Atomic size is decreasing. They won't tell you to draw and all. Okay. So why this is happening, beta? Because of the screening effect. F orbital का shape कैसा है देखो बेटा. These are the three lobes, huh? D block has two lobes. This has how many, beta? Three lobes. And their shape is diffused. Their shape is diffused. They will not tell you to draw, but you just remember. So what is lanthanide contraction? How to write the answer? The overall decrease in size of lanthanide with increase in atomic number is known as lanthanide contraction. Why this lanthanide contraction happens? They will ask this also. Why? Very important, give reason. Why lanthanide contraction is there? So for that, this answer you are going to write. I'll tell you the marking. Here. Page 185. As we move, there is a decrease in atomic size. This is called as lanthanide contraction. As we move from left to right, beta, atomic number increases, therefore nuclear charge increase. न्यूक्लियस के अंदर प्रोटॉन होता है, एक एक एटॉमिक नंबर बढ़ेगा तो प्रोटॉन बढ़ते जाएगा कि नहीं, बोलो बेटा, राइट? The new electrons are added to inner, which one? 4f shell. Inner 4f subshell. The 4f electrons shield each other and nuclear charge poorly owing to their which nature? Diffused. ये लिखना पड़ेगा. Why lanthanide contraction occur? तो क्या बोलने का? Last electron enters into n-2 subshell. That is 4f subshell. The electron in the 4f electron shield each other from the nuclear charge poorly due to their diffused. With increasing atomic number and nuclear charge, the effective nuclear charge experienced by each 4f electron increases. As a result, the whole 4f electron shall contract at a successive element. Now, what they will ask this question. First, what is lanthanide contraction and give reason for it. Secondly, what are the effect of lanthanide contraction? Effect of lanthanide contraction. So the first effect is what? Look, decrease in basicity. Then beta, that decrease in basicity, an effect of size of post lanthanoid. Effect in size of post lanthanoid. Now what is basicity, beta? Look, basicity. Okay, these are the hydroxide. Hey, tell me, beta, who's biggest? La was bigger. La is bigger in size or not? Tell me. Lu is smaller or not? Zia, tell me, beta, who is bigger? La se Lu, na, beta? Arey, when we go La to Lu, size will decrease or not? Tell me.
Yes.
Okay. Now tell me, what is the base? Who can give OH easily? Who will give OH easily? Whose bond length is bigger? Tell me.
La.
La OH easily देगा या Lu? ये देखना, ये distance is more. So
La,
this
la.
La. So as you go from La to Lu, so this will be most basic. And this
Yes.
is what beta least basic. So what is happening? Basicity is decreasing or not? Tell me, right?
Yes.
So look, I have given this. So if you see the size, it goes on decreasing. Can you see this? OH का साइज रिमेन सेम, बट M का साइज देख रहा है बेटा छोटा हो गया, तो ये डिफिकल्टी से ब्रेक होगा. So look, in exam they will tell you to arrange in the increasing order or decreasing order of basicity. So look beta, I have given here. Can you see? La is the most basic, then cerium, then Lu is the weakest base. Can you see? This is as per the Fajan's rule also. Fajan's rule, what is Fajan's rule? Larger the size of cation, greater is the ionic character. So because this will form ions very easily. Smaller the size of cation, greater is the covalent character. In exam, if I tell you question, who has highest ionic character, beta? Zia, who will have highest ionic character? अरे जो आयन आसानी से बनाएगा. Who will have the
Yeah.
highest covalent character?
Lu.
Lutetium. Arrange them in the increasing order of basicity. Will you be able to arrange them? Clear?
Yeah. It'll be La to Lu.
La to Lu. Very good. Then beta, we study effect on atomic size of post-lanthanoids. What are post-lanthanoids? I'll show you. Look here. Look, beta, this type of question will come. Decreasing order of, look, this is bigger. This is our La. La, and this is Lu. So this bond is strong, na beta? Post-lanthanoids. What do you mean by post-lanthanoid? This is periodic table. Beta, where are lanthanides? Beta, this here we have lanthanide contraction. Do you know beta here? La to Lu. So here there is what beta? Lanthanide contraction. Hey, these element beta, these element, the one in the pink. I'll circle them. Wait. These element are what beta? After lanthanum or not? Tell me. Array, they are after lanthanides or not? Tell me. Zia beta, they are after
Yes.
lanthanides. So they are
Yeah.
known as post-lanthanoids.
Yeah.
Now what happens across the down the group beta? Atomic size increases or not? Tell me. Down the group atomic
Oh.
size increases or not? So look at their values. This is increasing or not? Across the period, what should
Yes.
happen to atomic size? Decrease, right,
Decrease.
beta?
Yeah.
Okay, forget about them, beta. I'll write till here. Beta, if you see here, what is happening? Here, can you see atomic size is decreasing across the period? Here also it is decreasing across the period. Down the group also you see, beta. Down the group size is increasing or not? Tell me. But now I want you to see here, beta. What about this, beta? These are post-lanthanoids. These are post-lanthanoids. Can you see? Hello. Now I want you to see, Zia, what is happening to their size? Look, these two. This and this.
Mm.
Their size is almost similar or not? Same not. I have not used the word same. They are similar
It's
or
not
not? Tell
same.
me.
It's similar.
Why they are
Yeah, it's
similar?
similar.
Why they are similar? बढ़ना चाहिए था ना, because of lanthanide contraction. Because of
The Antonite contraction.
so अच्छा, these two elements their
Yeah,
size.
that 1 point, the 0.1 wala,
Which one?
0 point, no, 50. Was that picometer one?
Oh no, yeah,
0.1
that pico.
angstrom.
That was because of because here lanthanide contraction was happening ना. So because of that
Yeah.
lanthanide contraction, the आगे के element का decrease कम होते जा रहा है. तो because of that, these
Till
two element
overall
will have
will be
similar
that
size.
much, no?
These two element will have similar size.
Yeah.
And you know, beta, because that lanthanide का overall का size only 15 picometer was there. Therefore, lanthanide are placed separately in the periodic table because उनका सबका size almost similar है.
Hmm.
अच्छा, now these two element will have similar size or not? Look this. Okay, so the effect because of lanthanide contraction, the size of the element which were after lanthanide, so this means these are the post lanthanoid, they got affected, and because of that, these two will have what similar properties. अच्छा, इनका साइज अगर सिमिलर है बेटा तो केमिकल प्रॉपर्टी भी सिमिलर होगा कि नहीं? Their size is similar, so chemical property will be similar. They are known as chemical twin. They are known as chemical twin. Acha, why these element is in which series? This element is in which series? 4D series. This is 5D series. So element of 4D and 5D will have similar chemical property. Why? Or they are known as chemical twin because their atomic size is similar. इन एग्जाम में क्वेश्चन क्या पूछेंगे बेटा? ये देखो, ये पूछेंगे. Look, element of second and third transition series. Second and third transition series. That is 4D and 5D series. Have similar size. Therefore, they have similar property. Therefore, they are called as chemical twins. अच्छा, एग्जाम में पूछेंगे कौन किसका chemical twin है. In exam, they will ask who is chemical twin. Look here. Zia, who this is zirconium and this is hafnium. This is niobium and this is tantalum. Molybdenum and this is wolfram. Technetium and this is rhenium. तो इसको याद रखने का मैंने ट्रिक बनाया है. देखो बेटा. What is the trick? Look here. I've changed the spelling of giraffe. We are starting the giraffe ka spelling with what? Giraffe. Can you see? ZR is zirconium, half is half. Then you call cartoon character Nobita, Nobi no niobium. Can you see niobium? And Ta means tantalum.
Yeah.
Okay. Then beta we chow mao, mouse soup, molybdenum and wolfram. And beta there was a famous politician Bala Sahib Thackeray. ठाकरे को मैंने टाकरे कर दिया.
Thackeray.
या ठाकरे को टाकरे कर दिया. Technetium and rhenium. Because in MCQ they will ask zirconium has similar size with whom? Hafnium. Niobium nobita. Mao. Wolfram. Molybdenum with wolfram. Takre. So technetium with rhenium. Is this clear? Very, very important question, beta. So this was all about your lanthanide. Lanthanide हो गया. अभी बचा कौन बोलो बेटा? लास्ट. लैंथेनाइड के नीचे कौन होता है बोलो? Which element are below lanthanide? अरे फर्स्ट पेज पे ही मैंने दिया है. एफ ब्लॉक में 2 सीरीज होता है कि नहीं? Which one is another
Yeah.
one, बेटा? अरे बेटा, look here. This is which series? देखना, La to Lu was lanthanide. So actinium to lawrencium, this is actinides. This was 4F series, then this is what, beta? 5F series.
5FC.
Acha, actinium is again D block only, yeah? So this actinide starts from thorium to lawrencium, 14 elements. How to remember them? I have given mnemonic also for that. Look. Actinide is very small. छोटा सा ये देखो बेटा. Look beta, 3 planets, Uranus, Neptune, Pluto. Amitabh came in black in California, where Einstein and Fermi made noble lovers. So 3 means thorium, planet ka PA protactinium, uranium, neptunium, plutonium. Amitabh americum, came means curium, black means berkelium, californium, einsteinium, fermium. Mendelevium, Mendeleev periodic table you have studied na? Nobelium, Nobel Prize मिलता है ना, Alfred Nobel, and this is lover का is LR, Lawrencium. What is another name for actinides? Actinoids, second inner transition series or 5F series. अच्छा, they belong to group same ही है lanthanide का, but period it is 7. They will ask this general electronic configuration. वहां पे हम लोग 6 लिखते थे, यहाँ पे क्या लिखेंगे? 7. वहां पे 5 लिखते थे, यहाँ पे 6. वहां पे 4F लिखते थे, यहाँ पे 5F. यहाँ पे रेडॉन लिखेंगे, वहां पे जेनॉन लिखते थे ना बेटा. 5 1 2 14 0 1. Actinide is a D block. Starts from what? Thorium to lawrencium. Thorium to lawrencium. Total how many elements? Tell me. 14. Achha, who has half-filled configuration? This will have to buy at americum and curium. 5F7. Who has completely filled? Nobelium and lawrencium. This is very important. All actinides are radioactive. You know, we have studied physics में पढ़ा रहेगा, elements whose atomic number is above 81, they are what beta? Radioactive. अच्छा, who all
Yeah.
are naturally radioactive? In periodic table, natural element are till 92. So natural
Hmm.
radioactive element are actinium, thorium, protactinium till uranium. After uranium, बेटा, all elements are man-made. उसको हम लोग ट्रांस यूरेनिक सीरीज
Okay.
बोलते हैं. एग्जाम में पूछेंगे व्हाट इज ट्रांस यूरेनिक सीरीज. सो एलिमेंट आफ्टर यूरेनियम. पूछेगा
So
इट
they've
स्टार्ट्स
made up all
फ्रॉम.
these radioactive elements.
हाँ.
They've made up all these radioactive elements.
यस, मैन मेड.
By combining the
बाय
original ones
डूइंग
or
बॉन्ड
they...
फिशन.
Acha, okay.
Neptunium and ends with last element. Who is the last element in periodic table? Ununoctinium.
Oh,
Transuranic series. Natural radioactive are till uranium. A.
So
Yeah, tell me.
Organoson is the
What?
Organoson is the last element, right?
या बट अच्छा बेटा, पहले ना उसका नाम था यूयू ऑक्टिनियम, अभी उसका नाम हो गया ऑर्गेनिज्म. ऑर्गेनिसन. अर्लियर बेटा वी यूज्ड टू नेम देम. ऊनून ऊनियम, ऊनून बाइयम, ऊनून ट्राइयम. ओके, अभी उसका नाम ऑर्गेनिसन हो गया. राइट. नाउ, ए लेंथेनाइड कितना ऑक्सीडेशन स्टेट दिखाता था? +2 +3 +4. एक्टेनाइड्स कितना ऑक्सीडेशन स्टेट दिखाएगा बेटा? +2 to +7. ये याद रखना है. हु शोज द हाइएस्ट ऑक्सीडेशन स्टेट ऑफ +7? नप्पू. हु इज नप्पू? नेपच्यूनियम एंड प्लूटोनियम. अच्छा, बेसिसिटी ऑफ एक्टेनाइड्स इज मोर देन बेसिसिटी ऑफ लेंथेनाइड्स. व्हाई? लेंथेनाइड ऊपर होता है बेटा, एक्टेनाइड नीचे होता है, तो एक्टेनाइड का साइज बड़ा होगा कि नहीं? OH का साइज तो सेम ही है ना बेटा. हु विल ब्रेक इजिली? कम ऑन. जिसका साइज बड़ा है ना बेटा, तो इनका बेसिसिटी ज्यादा है. सिमिलरली एक्टिनाइड कॉन्ट्रैक्शन इज ग्रेटर देन lengthenite contraction. Clear? Oxocations means what beta? Normally oxygen has which charge? Negative. But actinides can form oxocations, means they can form compound with oxygen having positive charge. Oxocations. Okay, right. नाउ, एग्जाम में आपको क्या पूछेगा? पहला तो बेटा फर्स्ट फेवरेट क्वेश्चन, लेंथेनाइड एंड एक्टेनाइड्स का सिमिलैरिटी बताओ. चलो, व्हाट आर द सिमिलैरिटीज? सिमिलैरिटीज क्या बोलो? अरे, बोथ आर F block, राइट. लास्ट 3 शेल्स इनकम्प्लीट, दोनों में लास्ट 3 शेल इनकम्प्लीट. देन बोथ बिलोंग टू ग्रुप 3. ग्रुप 3 था ना दोनों. तो दीज आर द सिमिलैरिटीज, राइट. देन दे विल आस्क यू डिफरेंस. डिफरेंस में क्या लिखोगे बोलो? अरे, डिफरेंस में क्या लिखोगे? दीज आर द फेवरेट क्वेश्चन, सिमिलैरिटीज एंड डिफरेंस. लेंथेनाइड और एक्टेनाइड में डिफरेंस. लेंथेनाइड कौन से पीरियड में था बोलो बेटा? 6th. ये कौन से पीरियड में है? 7th. राइट. यहाँ पे इलेक्ट्रॉन कहां पे एंटर करता था? 4f में. यहाँ पे क्या होता था? 5f में. ए लेंथेनाइड में ओनली प्रोमीथियम इज रेडियो एक्टिव. ओनली प्रोमीथियम इज रेडियो एक्टिव. एक्टेनाइड्स में बोलो ऑल आर रेडियो एक्टिव. राइट ना? देन बेटा, इनका ऑक्सीडेशन स्टेट कितना था? +2 +3 +4. इनका ऑक्सीडेशन स्टेट कहां से था? +2 से +7. ये लोग ऑक्सोकटाइन नहीं बनाते थे. नो ऑक्सोकटाइन्स. दे फॉर्म ऑक्सोकटाइन्स. इनका बेसिसिटी क्या था? लेस. इनका बेसिसिटी क्या था? मोर. इनका लेंथेनाइट कॉन्ट्रैक्शन इज स्मॉल, एक्टिनाइट कॉन्ट्रैक्शन इज मोर. इजी.
Yes, sir.
हेलो.
Yes, sir.
बस देखो, F ब्लॉक का पार्ट हो गया. नाउ व्हाट ऑल क्वेश्चन दे विल आस्क, लुक. चलो बेटा इधर आ जाओ।
done, please.
हाँ
Done now.
हाँ, डन 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 बेटा, खाली क्वेश्चन देख लेते हैं, चलो बेटा आ जाओ। ए एलिमेंट टेक्स्ट बुक का एमसीक्यू खाली करवा दे रहे थे। एलिमेंट विच ऑल एलिमेंट्स आर रेडियो एक्टिव, विच आर ऑल आर रेडियो एक्टिव, बोलो। एक्टिनाइड्स। ठीक है ना बेटा। पैरामैग्नेटिक कौन होगा बेटा? पैरामैग्नेटिक मींस नो अनपेयर्ड इलेक्ट्रॉन। नो अनपेयर्ड इलेक्ट्रॉन किसमें होता था? जिसमें लालू नहीं होना चाहिए। ला में कितना होता था? F0 होता था। लू में कितना होता था? F14। तो ये वाला डिस्कार्ड कर दो, डिस्कार्ड डिस्कार्ड डिस्कार्ड, तो ये आंसर होगा। क्लियर? ए एलिमेंट विच इज अदर देन यूरेनियम विच एग्जिस्ट नेचुरली। तो नेचुरली कौन होगा बोलो बेटा? नेचुरली याद आ रहा है कि नहीं? नेचुरली में कौन होता था बोलो बेटा? यूरेनियम तक नेचुरल होता है कि नहीं बोलो? तो इसका
हाँ,
आंसर कौन सा होगा तुम्हारा? प्रोटैक्टिनियम। देन
calcium carbonate.
हाँ, ये देख, नहीं 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 नहीं, ये विच इज द मोस्ट स्टेबल ऑक्सीडेशन स्टेट ऑफ सीरियम। सीरियम का कौन सा था? +4। यूरोपियम का क्या था बोलो बेटा? +2। टुडे भी डेट ना बेटा।
Yeah.
देन these two question we have already done। फिर ये एग्जाम्पल ऑफ डाया पैरा तो हो गया बेटा। या बस बेटा, दैट्स इट। क्लियर है ना बेटा? लेकिन ये सिमिलैरिटी और ये
Yeah.
वाला आएगा क्वेश्चन बेटा, ये देखो बेटा, दिस क्वेश्चन इज वेरी इंपॉर्टेंट। Similarity of lanthanide and actinides. I have given in the, I have told you, हाँ ये रहा ये बेटा, similarities and difference. Page number is 188. Page number is 188. Can you see both shows +3, common oxidations, both are F orbital, right बेटा? Both radius decreases, both belong to group 3. Differences क्या था? lanthanide का +4 तक था, इसका actinide का +7 है। Lanthanides are non-radioactive. Actinide, only promethium was radioactive. All radioactive. Lanthanide do not form oxocation. They form oxocation. Most lanthanide are colorless. Actinides are colored. हो गया बेटा. Easy. Now I'm sending the paper. You all will write. Okay.
Yeah.
चलो then. Bye bye everybody.
Bye, thank you.